format, they should be capital Z, using this format here. I'm confusing,
so then that would be negative?
I'm confusing people. Further discussions, Sarah, you can come to my office. I will try to, and yes.
I think it'd be good for all of us if we figure it out now.
Yeah, no,
we do this again. We do this one more time. And I keep this, and let me work on this here. So let me draw this in a better way. So this is our original problem.
Yeah, just like the interpretation of this equation is going to be different from the way we interpret that one. So it's
and for here, for example, if here we pick, so let me pick a point here. How about that? So this is the point YZ. And the YZ here, any generic point, so let me pick the YZ, anywhere. For this quadrant, the YZ has a sign, positive, positive. For this one has positive, negative. For this one has negative, negative. For this one has the negative, positive, right? Okay. And now for this case, we decompose. And this is our my. And in this case, the upper portions is in tension, compressions. The magnitude of the stress for this one equal to the magnitude here is mz, and the neutral axis is about z-axis. And now we come to this point. Maybe I can use is.
So are you going to use the magnitude of your point, or are you going to use the so you're going to use the magnitude?
Any point here. So the point, for example, the point to the neutral axis that is given by this is z, right?
Yeah.
And at this point here, this distance. How about that? I just use whatever, I use absolute value. Not to use absolute, we can use this one. If the point is in the first quadrant, so the distance is very straightforward, it's simply z. Okay? If the
That's
point,
technically y. That's why.
if the point in this way, then its distance. We do this quadrant by quadrant. At this point, the magnitude is mz, and the distance is z, and the iz, right?
Is it the distance y?
From here to here is y, sorry. Yes. And now at this point, again, the distance is y, so the magnitude is my, mz, y, and iz, right?
Yes.
At this point, the distance is how much? The coordinate is y, and so the distance is minus y.
Yeah.
Okay, now we use this one. mz times distance and iz. At this point, the same, the distance is minus y. So mz times minus y and iz. Are we okay?
Yes.
Okay, now we try to formulate the whole problems. You can see this one come up with basically is using different colors. So this one basically minus mz, y, iz. The same thing, this one is minus mz, y, iz. And this one you can see right now, that is what that means. When we do the calculations, we calculate MZ, IZ, and here, this one, for whatever, we simply take the absolute value of the coordinates here. For example, here I take the symbol, simply I take the symbol y. And now this one represent actually is the whole 1, 2, 3, 4 equations, because you can see when y is positive, the whole thing is positive. When y is negative, the whole thing is negative.
So you're just taking the magnitude of both the moment as well as the coordinate, or yeah, like the absolute value of both.
I will stop here for further commenting, but try to use your own deduction to summarize the things for yourself. Everyone agree with me for this one? Right now here, this term is trying to summarize 1, 2, 3, 4 points. Basically here, this is the expressions for this quadrant. This one expression for this quadrant for 4 quadrants, actually we can unify using this equation. You can see for these 2 quadrants, y is positive value. The whole thing will become positive, not right into the positive sign, the tension. For the lower 2 portion, the quadrants here, the y in nature is negative value. So making the whole thing negative, although we didn't see the sign, but intrinsically the sign comes with this one. Okay, so that means this equation will be sufficient to represent the stress, magnitude, and attribute for this case, for the entire case like this.
So the y that you have boxed isn't the same y everywhere. It's going to be either positive or negative y
Yes,
depending on
yes. So y here depends on the point. That could be positive, could be negative, depends on you above or below. Okay? And we can do the same thing for the other case. So now for this case, the M is this. So this is our neutral axis. So now this is positive, and this is negative compression. So again, we put into 4 points. 1, 2, 3, and 4. Okay, and now the distance we're interested would be from here to here. From here to here. So this one would be, this point has the coordinate here is y and z. 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 And now we measure the distance. The distance from here to here is z. The distance from here to here is how much?
Negative z.
Negative z. Okay, so now at this point, the magnitude, at this point the magnitude is m y divided by iy and multiply with the distance, which is z. At this point, the magnitude of the stress is my, iy multiplied with the distance. Okay, distance. This one at this point here, this is my, iy times distance. And this one here is the my, iy times distance. And again, right now we have 1, 2, 3, 4 formulations. For this one, you can see the whole thing is, this one we calculated is the magnitude. And now this point just right into the tension. So here either we can add it up positive or not. The whole thing will automatically positive. The same thing like this point here. now to this point, the whole thing represent is a magnitude, and which will be which is always is a positive numbers. And now you can see this one. This one, I begin to confuse myself.
I'm sorry.
No, I can make it. For this case, this point and this point here, at this point here, naturally the z has couldn't get it. Anyone?
Is your negative sign on the z being canceled by the negative sign from being under compression?
I thought that the negative sign on the z represented the fact that it was a movement.
No, that's true. That represents the point.
I know, but the fact that it is in that position.
Anyone agree that this one?
The moment is not in.
Anyone agree this represent is the magnitude only? Right? This one is a magnitude. Magnitude is always a positive number. Right? Because here the distance, Sarah, you told me the distance is minus z, I remember.
Yeah.
So basically the minus this one is, so everything we calculated here is positive numbers. So this one result represent is the positive number.
So it becomes a minus.
And then we artificially we add the minus sign, because here we know that this point or this point is in compression. So here we add a minus sign here. We add a minus sign to the magnitude to indicate here it represent is a compressive stress. Okay, so thank you so much, and kind of give the bright light. So, are we okay? So in this way, you can see right now the magnitude with the sign, then that one gives us the right expression for the attribute and the magnitude of the stress. And then if we work on, literally, if we work on the sign here, so basically the two signs will cancel out. So basically on every 4 points, basically that represent in terms of the formulas is myz divided by iy. This one is working for every single point on this cross section.
So it'll always be positive then? That value will always be positive?
For this case,
yeah.
for this, magnitude is always positive. And here somehow we're using symbol for calculation. Symbol sometimes intrinsically may be negative, yes.
So if we take a negative z value and put it into your final little equation, then we're going to get a negative, right?
You can give a try. You can, right now, because I couldn't understand what is meaning negative 0 or 1, but you can give a try. Otherwise, you can come to me. I can work out with you for the details. Okay, so now for the second one is this. Then we simply take the superposition principle. And this is the stress for this one. Okay. Again, the bottom line of those calculations are try to disengage calculation of the magnitude from assigning the sign for tension or compression. Okay, and then you here you doesn't have to follow my symbol notation for the coordinates. You can have your own things if you, as long as you help yourself to understand the whole thing. Again, the key things is again disengage the calculation of the magnitude from sign. That's it. And then using principle, the superposition principle. Okay, and due to these kind of the detailed discussions, I have one more question I cannot complete. I will continue on Wednesday, hopefully. But in this way, the